There we go. There we go. Now we are in focus, ready to go. So it has been a while since I last streamed. In fact, a little bit over 2 weeks. I, I owe everyone a little bit of an apology because I promised I would be more active and I wasn't. Turns out I was literally swamped in work. I was not predicting that much work, and essentially every time you got time to stream, I was just way too tired. In fact, lately I've been going to bed way earlier than usual due to that. But now everything is back to the usual, back to normality. So I'm back. Just to give you some context from last time, I'm in the Grea Ypue region. So the same place I was last time, same region. Still hunting for Guardian sites. Haven't found any, but have found a bunch of interesting systems like an Earth-like world or two, many water worlds, some very big systems like 50-60 bodies. This is quite an interesting voxel that I'm doing. So tonight I need to finish this voxel, well, the part assigned to me of this voxel, which is the 300. 300 is the end. So I'm at 295, which has been mapped already, and I mapped everything already, and currently I'm in this moon right here, which turns out to be a shepherd moon. So let me show you what we are dealing with, if it works, because it took a good second there. So first of all, amazing atmosphere. It turns off, like the sunrise. This is a very slow sunrise. Is blue, but if we turn around, well, wrong way. Oh, we're not there anymore. Oh, Target, welcome in. Thank you so much for continuing your Prime subscription for 11 months. Wow. Thank you so much. Your support is amazing. As I say every time, absolutely not needed, but I already know what you're gonna say because you've been subscribing since the very beginning, so thank you so much. Well, turns out we are on the wrong side of the moon now. You can kind of see what I was aiming to point to, but oh, let me see if I can find it again. We're gonna get there, but I want to show you my visuals last night because I haven't played today, as you can clearly tell. Last night I played for like an hour or two before literally falling asleep. If I can find it. There it is. This was my visual last night. Same exact spot, but being a shepherd moon, it had this incredible view of the rings of this gas giant, which is also violet. Isn't this amazing? This is one of the coolest places I've ever seen in this game. Hey Oz, how are you? Welcome in. Hope you're doing well. Good to see you. So yeah, this was my view last night. I just decided to stop here because I was quite literally falling asleep while playing, and it was like, no, I need to go to bed, which was like, I don't know, 10:30. But I still want to show you, this to you. So I scanned this fumarole in front of me, but I still need to scan a couple. So it looks like the rings are down there, so that's where we are going. I also changed the ship from last time. I think last time I was using either a Cobra or an Eagle. I think it was an Eagle because I seem to remember Tom coming in, Tommy's side, coming in and seeing the Eagle. So I'll show it to you what is the view from here. It's a really cool one. For some reason I thought the moon was tidally locked, so I was expecting it to be fixed, but clearly it's not. Very curiously. Unless it is, but the game fails at... No, it is tidally locked. It's tidally locked, but it isn't. That's the issue. Tidally locked, but the game doesn't quite digest it. Anyway, here it is. This is the view. I mean, we are right on the edge of the rings. And if you don't know what a shepherd moon is, then I can show it to you some examples from the solar system. There's a couple of moons, maybe more, in the Saturn system that are shepherd moons. One of them is... Oh man, I was looking at like a couple of nights ago. Ida, I think. I think one is Ida. Or something like that. But there's two. I'm pretty sure there's two moons. One is within the rings, actually. One is the outer edge, if I remember correctly. Oh, thank you for hanging out here. Really appreciate it. I kind of want to go there though. Like, just have a front seat view. Of the rings, if I can. So now that my schedule is a little bit more open, I should be able to stream regularly. So next time, if I'm not too tired, it's gonna be Thursday. Now Thursday I have a conference, but it's a small one and it's here, right next door. So I don't have to travel. I'm giving a talk, but it's nothing. So unless I'm particularly tired, I should be able to stream. Otherwise, for sure on Saturday, I think. I don't have anything going on. So the schedule should go back to normal. This is lower than I expected it to be. Usually this is fast, but clearly it's not. It should be good enough though. And maybe I should go northern, because otherwise we are gonna see only very thin rings. It is a big shepherd moon. In fact, it's the only moon of of this gas giant. No, it is. I mean, you can guess by the gravity. It's like 0.22 g, which is fairly large for a moon. Where are the rings? Now the objective is to find the Fumarola, which is right here. Perfect. This was easy. Like to find that first one, it took me a while actually. I had to change spots a couple of times and then keep looking. I guess it's a matter of like different types of terrain. So yeah, I'm a little bit too close to the equator, so I guess I need to tilt to see the whole thing. Maybe from very low perspective. Yeah, almost. Next part. Maybe I'll go into a new spot. That's the view. It's quite an amazing view. I visited a few shepherd moons, but this one is possibly the most beautiful. Also because of the color of the gas giant. It's like violet is somewhat common, but not so much. Oh man. Look at that. I'm pretty sure that is a sunrise because yeah, it was coming from that direction and the sun was rising yesterday night. Also beautiful Fumarola. This is the Aquatis, I think. Yeah, Fumarola Aquatis. This shouldn't hurt. I can make a little bit of a composition here. Oh yeah. And then I'm very behind on uploading this to the Discord. Like all the screenshots. Like I have like something like 30, maybe more screenshots to publish there. They will go there. Just need to find some time. Because I also, usually I don't edit them. Like if I do some editing, it's just to maybe adjust the contrast a little bit. I never change the colors or anything. Also because I'm terrible at Photoshop, so typically I only use Photoshop to crop stuff and do very basic image editing for my work. I never do any artistic thing. Free sauna, oh yeah. Unless I actually don't know what kind of geysers are these. This could be actually very cold. In fact, it's probably gonna be water guy. Oh, it's water. So I guess you can say it's a sauna, but it may be a very cold one. But yeah, it's a fairly large moon. Radius 3.4 thousand kilometers. So it's almost the size of Mars. Size of Mars is almost 4,000. It's 3,700, I think. Oh, and I see. Wait a second. I need to adjust the lighting here. because otherwise the camera thinks, or well, better, OBS thinks that my face is part of the green screen, and it changes day to day. There we go. It was like half of my face was transparent. I promise I'm real. I'm solid. There's a solid head here, maybe empty, but it has a solid outside. Anyway, yeah. So let me check. Actually, radius of Mars, I'm pretty sure is it the equatorial one is like 3696, something like that. Radius of Mars kilometers. Oh no. 3396. This is, I think, the average radius. The equatorial radius is... No, they cite 89, but the official one is, I'm pretty sure, 3396, not 36. So this moon is about the size of Mars. The other thing is, if you guys don't know what a shepherd moon is, it's a moon, shepherd moon. It's a moon in a planetary system that is very close to the rings of that planet. So the most notable ones are Pan, not Haida. Pan. Pan is one. The other one I was thinking of, I think it's Prometheus. But Pan is the most famous one because it has this kind of burger sandwich appearance, you know. It's like the two buns and this thin edge, which is actually the ring material being deposited on the moon as it travels through the rings. Yeah, there's a better picture of it, so you can kind of see the overall shape. It's like almost, you know, somewhat spherical, roundish shape, but then it has this slice at its equator, sort of. It's not really an equator because it's probably wobbling around a bunch. It's probably tumbling. Here is a view from Cassini. It's tiny, but these are essentially the rings, all these materials you see, and this is the moon, so it's accreting ring material across its equator. Other pictures, there's a very nice one. Okay, there's this one. There's this one also. I mean, all these images are from Cassini. These are the rings of Saturn. There's Pan right in between the gap, which the gap between the rings are actually formed by the moon itself. The moon is scavenging materials from the rings. There's an even nicer picture of Saturn rings. Which shows the interaction with the rings. which is very beautiful. There it is. Daphnis. It's Daphnis, not Pan. Daphnis. Daphnis is the other important one. So there's the moon, Daphnis, also part of the Saturn system, and it's interacting with the rings, making these waves in the rings, which are not only horizontal, but they also have a vertical component to them. There it is. So this is kind of a, an oblique view of the rings. So this is I'm pretty sure this is the outside of the rings. This is the moon, Daphne, the shadow of the moon of the rings, and then the deformed rings, like making waves and casting their own shadows onto the other rings. So quite beautiful, in my opinion. Really, really nice. And this is actually very useful to some planet dynamicists, because it's like a test bed to test and prove like orbital dynamics, because essentially you have a something that you can simplify as to a point mass, the moon, that has enough mass to create its own gravity, and it's interacting with many other bodies, in fact, like a continuous sheet of bodies, like a continuous distribution of bodies, which are the rings around. So you can do like these many particle simulations and try to simulate how these particles will interact with the moon, which is quite important in planetary formation, because essentially this is how planets form in protoplanetary disks, which is actually one of my subscriber a little emote thing. It's one of them is essentially a planetary accretion disk around some star. It's of course in form of a cartoon. I had an artist design it, but it's based on real imagery. So for example, like planetary. I can't write tonight. Yeah, this is one of the most famous pictures. It was taken by ALMA, I'm pretty sure. Yeah, ALMA, the Atacama Large Millimeter Ring. It's one of the many protoplanetary disks that have been imaged by these kind of systems, radio telescopes arrays essentially. So they use many radio telescopes distributed along a wide area to essentially create an artificial, very large telescope that can take very fine detail images. This is in microwave. In the microwave region, this is not visible, of things like protoplanetary disks. And so you see these are actually many different rings. At the center there's a star. It's an HL Tauri. I guess that is the name of the star. And this is dust and gases, mostly dust I think, that emits microwave radiation and is captured by the telescope. But the gaps in the rings are most likely formed by planets forming in this exact way. So there's a planet accreting dust and probably gases too from the disk, taking it for themselves, and accreting into protoplanets and eventually planets. In accretion disk, exactly. There's many examples. Somewhere there's a very nice compilation of it. Let me see. It's probably not on this page. Yeah, this is it. This is the one I have in mind. Uh-oh. That's weird. No, who cares? It's like an EDU website. It's like almost a government website. What's wrong about it? I'm not sure if the one I just showed you is here. I don't think it's this one. But these are all protoplanetary accretion disks. And they have all sorts of shapes, depending on how far into their evolution are going. Oh, there's certificate expired. Yeah. These are actually, looks like maybe two in the same place. That's interesting. So, you know, from just a tiny little, you know, seemingly insignificant moon, which is like tiny, tens of meters, hundreds of meters in diameter, in Saturn we can actually learn so much about how our own solar system formed, but even other planetary systems. Like, if we didn't have that, we probably would have more trouble figuring these things out. So we need to be thankful of what we observe in our own solar system. So let me catch up with chat. You're learning stuff on the internet, Oz? Absolutely. Every day, basically, I learn something. Because I lurk, even if I'm not streaming or playing, I always lurk, often more than one stream at a time. And every day I learn something. If it is game, science, whatever, I learn something. Like earlier today in Arduino was talking about Planck telescope, and I learned... what did I learn today? It was talking about the cosmic microwave background, and he said something that I didn't know. I can't remember it though. What was it? He said something about the instrument. Can't remember. Well, also have memory issues probably. Anyway, it's crazy how thin the rings are. Yes. Beast. No, I did not hear about Beast. He was talking about Planck. And he said something about... Maybe it was not about the instrument itself. Maybe he said something... I don't know. I was also distracted because I was actually having dinner at the time, so I was kind of distracted. But yeah, anyway, this is what a shepherd moon is. We are on 1 in game right now. So did I scan? Yes, I did scan. So we are good to move up. Oh wait, I can actually just go here. I love this ship, it's so fast. Also dangerous because I'm currently holding 160 millions of exobio data. without bonuses. So with bonuses, that would be 800 millions. So I need to be careful, actually. Oh, wait. Did not realize I was max throttle. Oh, I just remembered. Nerduino was talking about the cooling system, and he mentioned it's or it was based on liquid helium, and I didn't know they needed to cool it down to such low temperature, but it all makes sense. Because I always assumed, like, I know there's like electronic noise, so if you want to measure radio waves and that kind of stuff, you need to keep things cool. But I didn't know it would needed to be that cool. However, it completely makes sense, because if the cosmic microwave background is 3.7 Kelvin, 3.9 Kelvin, I guess you need to cool it below that. Otherwise, you're just gonna measure the
sample collection complete.
Your own temperature, the temperature of the sensor itself, like the antenna and the receiver, which it makes complete sense. But for some reason, I thought, we have radio telescopes on Earth, and they measure things. I mean, they keep it cooled, but I don't think they use liquid helium. But that also makes sense, because the protoplanetary disks that I just showed you are probably very hot, like hundreds of Kelvin. So as long as you are below the temperature, you're good. Your noise level is below what you're trying to measure. But yeah, it was like so obvious, but at the same time, like, not. I didn't know you needed to cool something like that. I know you need to cool things like infrared spectrometers and that kind of stuff. Even other instruments like, for example, some gamma ray spectrometers. There's the gamma ray spectrometer on Mars Odyssey. Was cooled. It was kind of passively cooled by a radiator, but it was cooled to like 180 kelvins, because otherwise it was too noisy. And that was to measure gamma rays, which are very energetic, but for the detector, which was a germanium detector, I'm pretty sure, it needed to be very cold. And in fact, on Earth, those same detectors are cooled with liquid nitrogen typically. Otherwise, you're just gonna measure like electronic noise, which is of course not good. You want the sensitivity to capture the signal of every single gamma ray that hits the detector, which are not many, especially if you are like orbiting Mars. It's very distant from the surface, so there's only a few counts per second. There's only a few gamma rays per second. Also because it's difficult to measure gamma rays, because they tend to go through stuff. they don't interact that much with stuff. Which is good on one side, at the same time bad, because when they do interact, they pack so much energy, each single photon, that they do a lot of damage. They disrupt entire crystalline fabrics, so they don't only break our DNA, they can even like weaken metals, because they disrupt the crystalline lattice of of metals. Same thing applies to things like neutrons. Neutrons tend to really weaken a lot of metals. Like, that's one reason why nuclear reactor vessels are typically an alloy of zirconium. Zirconium is particularly resistant to radiation bombardment by neutrons. Another bad habit of neutrons is to transmute stuff, so they interact with other nuclei and tend to turn them into something different. So leave something next to a neutron source for a little while, it literally transmutes into something different. Like, you can make you can turn elements into other elements. It's quite it's quite a fascinating subject, actually. Oh, an ammonia world. I haven't seen one in a while. Look at that. Don't get exposed to gamma rays in space. Oh yeah. Gamma rays in space are particularly harmful because they are extremely energetic sometimes. On Earth we are lucky because there's an atmosphere protecting us from the vast majority of gamma rays, so we don't really have to worry about them unless typically we create them or we are next to a natural source, like some mineral rich in like things like potassium, thorium, uranium. Like some granites. Some granites tend to be particularly radioactive. I once was visiting Vienna in Austria, and there's a statue there. Ooh, a ring demonic word. Look at that. What about that? And so this statue is made of a granite which is particularly radioactive. And I can't remember the full story, but they had to issue a special permit to either install the statue, put the statue in that place, or to keep it there. I can't remember which one it was, but it was like beyond the typical exposure limit. I mean, no one lives near the statue, but if you sit there for a long time, I guess you can get an higher than usual dosage of a variety of ionizing radiation. It's probably a mix of like alpha, beta, gamma rays. Yes, Earth is mostly protected by gamma rays. I mean, we still detect some, but typically they are due to cosmic rays, which are not necessarily gamma rays. They are sometimes just very energetic particles like protons that go extremely fast, like very close to the speed of light, and so they pack a lot of energy, and when they go through the atmosphere they cause a cascade of particles that includes gamma rays. So the gamma rays that we typically measure on Earth are due to actual particles that hit the atmosphere.
First body to map is 1.
Now I'm also keeping some statistics here. So we have 3 potential guardian ruins, which are not there, unfortunately. 1, 2, 3, 4, 5 brain trees. There's also an oxygen atmosphere, which is not interesting. There's a few other things, like, wait, 6A, this guy that I need to map, and then your morning world. So long as nothing turns into a pulsar near us with its pulse facing us, yes. Yes. Yeah. Or a supernova. A supernova happening near us, that would be bad. In fact, I think it's the... I think one of the mass extinctions is thought to be due to a supernova. If I remember correctly. One of them. The Permian one is the very big one, but that is not. That's not the one. The Permian extinction was like over 90% of species. This one. It was absolutely no, okay, 84% of marine genera. Well, close to it. 84 is pretty close to 90. This is the very big one. But there is one which is thought to be due to... Need to keep an eye on this, otherwise I'm gonna overshoot it. Let's do this. Of course, if any of you guys remember which one, know which one, feel free to say, no spoilers here. This is something that is fairly well known. You know what? Here. This one. So, a gamma ray burst caused the end Ordovician extinction, and the supernova has been proposed as the cause of the Engenberg event, which is the... I'll need to move this on the side. So I'm reaching destination here. The Engenberg event is which one? Devonian 358. Devonian 358. So... wait, which one it is then? Oh, that's a pretty one. This. It's beautiful. Very large polar cap. Or at least I think it's a polar cap. Devonian.
Mapping complete. Next body
Oh,
to map
late
is 1.
Devonian. So here, one of these. 6, 7, or 8. Probably 6 or 7. It's possibly one of these, I guess. No, wait. Probably this dip right here. I guess that is the one. Yes, and absolutely, very good. Very good observation. There's, we tend to think that there's only a few mass extinctions. Actually, there's many. There's been many of them. We just tend to record the major ones, like this one, this one, this one, this one, this one, maybe this one too, or this one. But in fact, there's just been many. The only thing is that most of them are only a smaller fraction. Like, if you count just those that are less than 20%, is the vast majority of them. But especially early on in the Cambrian, like if you were a species in the Cambrian, I mean, look at this, like 40-50% every few million years, like 50, imagine 40-50% of all species eradicated completely. Let's start again. And then after a few million years, again and again and again and again. Like, look at these three. Like here, like this one was 60%, 45%, over 50%, another one almost 50. It's like, man, it's like an horrible period to have lived in. I didn't want to be a trilobite at the time. If you've never been here, that's one of the greatest places to ever go. You can literally put your finger on a mass extinction event. In this case, the KT boundary, or the KPG boundary, which is the Cretaceous extinction event, the last big one, which is the one that killed the dinosaurs, or at least the majority of them. So I was there because this is in Gubbio, Italy. It was one of my first few field trips in college, and you can literally put your finger on this layer right here, which is a very dark layer, and it has an anomalous high concentration of iridium. I don't know if they are gonna show it, but if you look at KT boundary, it's everywhere. It's not just in Italy. In Italy, it's one of the best places to see it. Oh, come on, they don't show the other most important thing? Seriously? Oh man, we need to correct this. KT boundary iridium. Iridium. Come on. There it is. There it is. So this is the concentration of iridium. The problem is that it's logarithmic. There it is. This is linear, I think. Show me the linear plot. Show me the linear plot. Here. No, this crappy one. There it is. So, you have these rocks. Let me put them side to side. Or was it this guy? So this picture. No. Here. This picture and this plot. You're learning geology here. Mostly paleontology, but geology in general. Um, um, so this is this Cretaceous limestone marl. Don't remember what it is, which is actually this material right here. I'm pretty sure. I don't think this has been overturned, so I'm pretty sure it's this stuff. And then you have the layer, the high concentration of a bunch of stuff layer, which is very dark. You can kind of get this an idea that it is particularly dark. And then there's this other material that is on top of it, right? So there's a bunch of microorganisms happily living here. In fact, you can see the fossils. And then at some point they are gone. And not only they're gone, the rock itself changes color, changes fabric. And this thin layer right here, if you do a chemical analysis, you will find that the concentration of iridium increases exponentially. Like, this is the background level of iridium. Iridium is an extremely rare element on Earth. It's extremely hard to find. It's like platinum or that kind of stuff. It's a precious element. And then it just shoots up like many times, like orders of magnitude, like 2-3 orders of magnitude, so hundreds, thousands of times. In this case, in Italy. The impact happened in Mexico, in Chicxulub, Mexico. So, like, on the other side of the Earth, you are recording thousands of times increased concentrations of iridium, and then it goes down again. And the reason for this is that because there was an impactor, a big one, an asteroid that was rich in iridium and impacted on the Earth and released iridium everywhere in the atmosphere. And then as the dust settled down, so did the iridium, and it's preserved right there. So, like, the possibly the biggest smoking gun that the big impactor caused this extinction event, iridium. So next time you hear about iridium, now you know what to think of. The poor dinosaurs killed by the asteroid. And I see there's been tons of messages in chat, so I'll catch up, I promise. I tend to go on to these monologues about science. I get excited about science very easily. Oh man, I see I have ads incoming and I cannot skip them. So let me try to catch up before they start. Otherwise, I'm gonna take a break as soon as the ads start. So you don't have to look through the ads. You can just walk away, do whatever you want. I think most of people know of maybe two. Yeah, the most famous one is the Cretaceous one, the dinosaur one, and the other one is probably the Permian one, which is the big one. Maybe, yeah. And there's a third one which is happening right now. It's kind of sad. We are the cause in that case. I think we killed already, what, 10% of species, something like that. Oh, ads. So I'm gonna take a break. See you in 3-4 minutes. All right. I see the cow doesn't believe I'm a doctor, so here it is, sporting real doctor clothing. Hawaiian shirt in the background. Anyway, so let me catch up with chat because there's a ton of things. Life just never gives up. Cockroaches, damn it, lived through all of it. Yes. In fact, a lot of other life. You know, sometimes like almost 90% of life went extinct, but we managed to persist, or better, our sense as ancestors managed to persist. Hawaiian looking ass. Well, I actually wear Hawaiian shirts basically every day. It's something that I picked up many years ago when I first went to Hawaii, and I was like, this is great. This is how I want to dress from the time being. Hans tried a uni science degree when left high school. The head lecturer drove a Miata. That's awesome. And the 2 published articles in Nature magazine. Oh, cool. I never tried publishing in Nature Science, but I know many people who did. My advisor has at least a paper in Nature and 1 in Science. And I know it's not that hard actually. You just need a cool story. Miatas are based and good, absolutely. Owned 3 Miatas. Wow, damn. I keep looking there because that's where my camera used to be, but I should point there. Sorry about that. No published article in Nature. Well, you're always in time. You just need to come up with a good story. I feel like 99% of the time I talk to Nozimo, the English has gone unheeded. Mine for sure. Sometimes I just can't speak or write or both. Associate professor was cool. You're bipolar and would have finished otherwise. Times have changed. Fortunately, academia is starting to realize that some of us have different challenges, and we are trying to make it a more inclusive environment on that side as well. Never give up in that case. Back then, sure, there's still bad people in academia that shouldn't be there, but we're trying to do our best to recognize everyone's obstacles. I feel like Nozima is ignoring chat in favor of nerd shit. Absolutely. I unfortunately tend to do that. But now I'm catching up. Cackles in Twitch Turbo. Yeah, I try to run advertisements only 3 minutes every hour, so people don't have to go through them, because I really dislike ads. I wish they were not there. In fact, I've been thinking of just giving up affiliate just to go back to having no ads. You drink even harder than me. Get another bottle. Cheap ass whiskey. I don't drink hard stuff. I don't know. I just gives me nausea. I guess it's kind of a lucky thing I have, because otherwise I would probably be drinking that stuff. He started with wine. Wine is good. I only recently, last few years, started to appreciate wine. Oh wow, that's quite a bit of road. In fact, in probably a couple of weeks, I have to drive 900 miles, probably in 2 days. But I've done it in 1 day too. Put the scope on Earth's heart. I kinda did actually once. In my PhD. After my PhD. Oh, thank you, Oz, for the donation. Really appreciated. Let me see if I can find it. In the meantime, let me go to Play Dangerous. You don't really need to watch me. It's probably an eyesore. There it is. No. You can't really see it. But this was my uniform when I got my PhD. So this exact uniform. This is my advisor check. And I have another picture, but you can barely see it, where I'm holding the stethoscope, this stethoscope against this rock, which I call the brain stone, because it kind of looks like a brain. Unfortunately, it's not here, it's in my office. I keep it in my office on top of a stack of papers. Oh, yeah, you can see it. Because it kind of looks like a brain. And this is my geologist hammer, which is not here, it's in the other room. But I've done that. I've used the stethoscope on a rock before. Absolutely. Doctorate is not PhD. In the US it is. I'm a doctor because I have a PhD. I'm not a medical doctor though. So I'll actually stop pretending, especially because I'm really warm right now. It's kind of hot here in Arizona right now, so I don't need any extra layers. That bang you heard was my stethoscope. Never really used it. I mean, I tried to learn how to listen to like noises and stuff, but it's kind of complicated. What do you do with that? Listen to rocks moan. I wish. Wine is good. Wine is good. All right. Thank you, Astro, for staying around. Thank you as always. You're always there. I really appreciate it. Did the 300 miles over 2 days. Hurt my soul, but my brother got to visit our dad. Oh, okay. I'm sorry to hear that, but hopefully everything went alright. I know long drives can be stressful. Typically, I put on an audiobook just to distract myself, because otherwise it's so alienating and repetitive. Is kind of bad. Oh, thank you, Astro, for a donation. Yeah. You're so supportive. Thank you. Really appreciate it. If he asks you guys to cough, guys, run. No, I said it. It's complicated. I learned very quickly
Mapping
that
complete.
it's
Next body to map is
it,
1.
there's a reason why it takes like 10 years to become a doctor, a medical doctor. I tried to do it in a few hours. I was like, nope. All right, this is done. I think I've caught up with chat. I'm particularly bad at catching up with chat. I was tripping. Don't worry, you'll never see any bad sides from me. You can stay sure of that. Okay. Actually, you know what? I kind of want to check out one of the brain trees while I'm here, if I can. Let's see if there's any close by. 5A is probably the closest. Yeah, let's go there. Because I'm not sure. I don't think that just scanning them will actually report them anywhere. So I like to actually, composition scan brain trees at least once every system I find them. Just for the statistics, also because I'm missing a few species. Missing at least a couple. And I know they are here in this region, so I want to find them. Otherwise, I'm 4 systems away from finishing my survey. Uh-oh. What? What? I got... Oh, okay. I just got this weird-ass text. Ugh. There's probably someone protesting on campus, and I'm getting these emails like of unlawful assembly. Don't go to campus. Like, I'm not going to campus at midnight. It's like, if I need to go to campus after 7 or 8, it means I forgot something in my office, or I need to pick up something in my office. But I bet there's someone protesting. There's so many things going on right now that I feel like everyone is protesting about something. Not judging, just I guess it's a signal that a lot of people are in distress. Things need to change. But it looks like the police is being the police as usual and being dramatic about it. In fact, now that I notice, even if I add phones, I'm hearing a helicopter making circles. I live fairly close to campus. Yeah, there's definitely an helicopter going around. Oh well. Hopefully no one gets hurt or gets in trouble. That's the last thing we need. Oh, what's that? Oh, of course. Oh, I forgot to tell you guys. I got to Elite 5 in exobiology. This happened a few days ago. It was quite a nice event. Something I've been working on for over a year. So I am happy to report, and I now reached Elite 5 in exobiology. It took a while. Let's just say that. Now, next step is to get elite in probably combat. As soon as I'm finished with this trip, I'm probably gonna head back to the bubble because I want to do some Thargoid combat again, and some ground operations too. I kind of miss them. It's been a few months, so I want to do that again for like a couple of months, something like that, over the summer, and then go back to exploration. Looks like we only have these roseum trees. Let me check if they are actually the same pink. Yes, they are. Yes, they are. Okay. Okie dokie. Next system. Probably news helicopter, but yeah, peaceful protests don't need intervention. I honestly don't know if it is a protest or not. Like, the only thing they say is... Let me read carefully here. A lawful assembly, PD responding to an awful assembly at... Oh, it's not even on campus, it's near campus. Oh, it's right here, actually. No, wait. It's not right here. It's a couple of blocks that way. But fairly close. Fairly close. Yeah, a couple of blocks in that direction, right there. Probably just outside of campus. Police on scene, close to traffic. It's either a protest or some drunk people. It could be drunk people, but on a Wednesday? Tuesday, Wednesday? That seems... I mean, there's nothing going on right now. Like, it's finals. It could be a drunk student on finals. But it's an assembly, so it's more than one person. It's like a group of people. I don't know what constitutes an unlawful assembly, like how many people, but it must be at least you. Well, thank you for the congrats, Marcuso, and Oz again. Exobiology is fun. You always find something cool, something new. Like that fumarula. I may have not checked that Shepherd Moon if it wasn't for the fumarula. And for some reason I turned off orbit lines. Don't want to get too close. This was a big system, I think. 46? 48 bodies. As I said before, this box is full of big systems. The largest I found, I think, was 60, 70, something like that. Alright, looks like we have a water war too. Helicopter is still going. Where is it? Is it the moon? I saw it. I saw the scene. No, it's not the moon.
Body 5.
But it's...
Meets mapping
No,
criteria.
it's not even a binary system. It just happens to be close. Interesting.
Body 4A. Potential
Time to make dinner?
guardian
Well,
marine body.
have a very nice
Horizons
dinner then.
biopresent.
Thanks for hanging around. Always appreciate the lurk. And chat, of course.
Body 4D.
Hope you have
Potential
a
guardian ruin
nice
body.
rest of your night.
Body 4C. Potential guardian ruin body. Body
Okay.
4B. Potential guardian ruin body. Horizons biopresent. Body 3A. Horizons biopresent.
Okay. Another round. So it's like every 2 minutes. It's making a circle every 2 minutes. Something like that. Could be news, but unless it's something
Body
big,
9CA.
it's probably gonna be police. I don't even know if there is a news helicopter here in this town.
Body 10.
There
Wide
could
rim.
be though. I wouldn't be surprised if there is one. I'm also not far from an hospital, so every once in a while it's an helicopter rescue. It's like one of those helicopters. Which is also never a good sign.
Body 6C. Potential guardian ruin body. Horizons biopresent.
Lots of brain trees.
Body 6D.
Look at this, it must be
Potential guardian ruin body.
10 of them.
Horizons biopresent. Body 6A.
Wow.
Potential guardian ruin body.
Yeah, I would like to
Horizons
see
biopresent. Body 6F.
Like to see a
Potential
guardian
body.
here in yellow
Horizons
orange,
biopresent.
not just a white nun.
Body 6E. Close binary relative to body size. Potential guardian ruin body. Horizons biopresent. System discovery complete. First body to map is 5.
Alright. It's quite a big system. This. The only known gas giant, well, no, actually, this is not gas giant either. But no, there's one cool grand dwarf that doesn't have rings. Otherwise, all the planets have rings. So cute. There's like 10 of them. Let's see. 1, 2, 3, 4, 5, 6, 7, 8 potential guardian ruins. And 1, 2, 3, 4, 5, 6, 7, 8 moons with brain trees. Avoid some close binaries. Okay. Nothing else. Alright, number 5. Here we go. Hey Matt, how are you? I'm finishing up this, well, this assigned section of my voxel, so using your software right here. Guys, if you don't know, Matt G is one of the developers behind a lot of the third-party tools that we use every time we play this game. Don't forget to say thank you. It's amazing the work you guys do for the community. Cool rings too. It's like kind of thin and distant. Still for probes and rings. Yeah, and Elite Observatory is the other one, which is running in background. That's the voice you hear is Elite Observatory.
No more bodies to map.
Okay. Let's find the closest, which is probably... Wait, let's see. There's Guardian... What? Horizon Bio is almost everywhere. Let's see, 3, 4, 6. 4. 4B. There we go. Right there. just next door. You do some of the plugins. Yeah, Vithigar and FJK are the other developers. FJK sometimes comes around, otherwise I see him in other streams. He hangs around. I mean, I love all these tools. They are one more amazing than the other. Oops, 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 oops. Ah, no. There's gonna be a loop. See if I can graze it. Yeah. I found that if I can graze the planet just right, it slows down quite a lot and lets me come back very quickly. But it was a loop, so I need to keep tabs here. So Matt, actually, this could be a good question for you, because you probably know the answer. Do you know if there is any reporting of brain trees? If I just do the, I guess, the FSS and the DSS without actually comp scanning the brain trees themselves, like in, I don't know if journal processor or maybe market connector, if it does it, or if I actually need to do the comp scanner, because I've been doing the comp scanner for at least one brain tree plays in every system, just to make sure it gets recorded in some stats website, some database, because I know there are databases for like the different type of bios and that kind of stuff. But I was wondering if I can just skip it. If it is like a kind of a futile exercise. Or better, more than futile, like unnecessary. Because I'm actually interested in seeing if there's anything new here. Because I'm like, I'm missing, I think, 2 brain trees that exist here. This one, and it's in a D mass, so if I can find a suitable place, otherwise I'll just go here and oh no, maybe it's the only one I can find here. Not sure if these other can be found. This region. Anyway, I'm probably gonna do comp scanning anyway. From FSS, no. If you map a body, it reveals the genesis of the body, and Spench records that. Okay, okay. If you come scan, it will record the species variant. Okay, that's good to know. That's very good to know. That's kind of what I suspected. But good to know. I'll just keep comp scanning everything, so I'm sure that way nothing is missed. Because I'm sure someone may be interested in some like statistics, like what is the concentration of brain trees in the region compared to density distribution of guardian sites or particular planet types, star types, whatever. I'm sure there's like ED scientists who feast on the type of statistics. Shouldn't go across, but oh well. There we go. Better. Right, 3 systems to go. Unless I find something major like a lot of bias or stuff like that, I should be able to finish tonight. Which is actually what I wanted to do.
Body A, B, C, D, 2. Wide ring. Body D. Close binary relative to body size.
Ooh.
Sir, Romulan warlord
Interesting.
looking directly ahead.
Boss lady, welcome in everyone. Thank you so much for the raid. Hello everyone. How are you? I didn't see you streaming earlier, so I didn't know you were streaming. How's it going, everyone? If you don't know me, I'm Dr. Nazimo. There is no correct or wrong pronunciation, so you decide how to pronounce it. In real life, I'm a planetary scientist. I'm, in a sense, a real doctor. In fact, there was something happening earlier. I won't speak too much about it, though. And I play Elite. Sometimes I like to throw in a little bit of planetary science. Like earlier today, we were talking about shepherd moons, was forgetting the term, and mass extinction events. Currently, I'm trying to finish my assigned portion of a little voxel survey in the Grea Ipue region, which is a region with several guardian sites. In fact, all these waypoints are guardian sites, as far as I know. And this region is located about halfway to Sagittarius A star, the galaxy core from the bubble. So 20,000 light years? No, 14,000 light years. So kind of close by. Anyway, welcome in everyone. Looks like your auto shutout worked correctly. How are you doing? What were you doing? I'm curious. Were you exploring? Were you doing some Thargoid stuff? There's lots of stuff going on right now. In fact, I'm after I finish this, I'm probably gonna go back to the bubble myself because I want to I want to do something with the Thargoids, the Titans. I haven't done anything with the Titans so far, except gather some materials a few months ago. Deep space exploration. All right, all right. I'm curious. Where are you? Which region? Deep space exploration is my favorite in this game. I started playing this game because of
Body
the
A, B, C, D, 2C.
exploration and science
Shepherd
content.
Moon.
Oh wow.
Body A, B, C, D, 2D. Carbon dioxide atmospheric landable with life. Shepherd Moon. Body
Talking
A,
about
B,
shepherd
C, D,
moons.
2B. Shepherd Moon. Body
All
A,
shepherd
B,
moons.
C, D, 2A.
Oh, I know
Shepherd
why.
Moon.
It's because this guy, wow. This brown dwarf has very wide rings, probably the outer rings, and so all the moons are shepherd moons. Headed east about 16k light years from the bubble. East, so you're probably where I was until not long ago. Like, what's this called? Like Achilles Altar, those places. Hawkins Gap. It is an exploration courier. It is an exploration courier. One of my favorite ships. It turns out it's quite good for these voxel
Body
surveys
A, B, C, D, 1F.
because
Sulfur dioxide atmospheric
most of the
landable with
times
life.
it's just a single jump, at most two. And I mean, I don't mind extra jumps. It's just more exploration.
Body A, B, C, D, 1D. Ammonia atmospheric landable with
So
life.
unless I need to travel fast, this is one of my favorite ships.
Body A, B, C, D, 1A.
Oh, you're building one? Nice.
Potential guardian ruin body.
Sure thing. I'll be very happy to share. I don't have the Coriolis, I have the
Body A, B, C, D, 1B.
Etsy.
Potential guardian ruin body.
The Etsy link. So let me find this planet, which is hiding somewhere. Okay, let me see. Because I have a list of here. I have a list of all my ships. So the exploration courier is this one. There we go. And it has been a while, so I don't remember if yeah, okay, it's like everything is almost maxed out. I typically do grade 5 to 80%, but looks like in this case I did the FSD to full 100%. Otherwise, my target typically is 80% because the difference between like 80% and 100% is so small that you will never notice in practice. I just tend to be kind of a perfectionist, so especially for the FSD, I like to max it out. But even if you do, like, let's try 50%. So right now the unladen range is 45. If you do 50%, it's like 44. In practice, you're not gonna notice it. But yeah, this is pretty much the exact shape I have. And for the DSS, I have this pre-engineered DSS. That's what I used on at least 2 ships. In fact, one of the goals of going back to the bubble is going to be to get the pre-engineered DSS on everything. The pre-engineered DSS can be found in systems, stations that have the human tech broker. So let me give you an example. If you go to Inara and you look for, so search nearest. Thank you, Kevin Connors, for the follow. Really appreciate. Welcome in. That's you. Sorry. Here. So, well, it's not gonna turn out anything, but let's say you are in Shirarta. You look for human. Oh wait. Technology broker. Yeah. Technology broker. You go to a station with a human technology broker, such as this station right here, but I mean any of these stations will do. And engineer DSS here. You will find that one of the options is this engineered detailed surface scanner V1. To get it, you will need 24 niobium, 28 mechanical components, 22 germanium, 26 mechanical scrap. So mechanical components, mechanical scrap is easy to find. Mechanical components, fairly easy, grade 3, so need to do some digging around, but otherwise you can find it. Niobium, germanium may take a little bit more time. My suggestion is always, if you have an exploration ship, to go to the crystal shard sites or the brain tree sites. You can find both. If you just look for, this is what I would do, and there's like there's lists around. Otherwise, you can look here in this list I made for myself. These are the location of the shards. I don't think I have any secrets here, so if you want to, I can share it with you. Let's see. Can open the link. Oh, okay. Yeah, okay. It is just viewer. I'm fine. Here we go. If in case you want it, there's gonna be stuff that it probably doesn't mean anything to you, but it's like this stuff right here. It's like my first discovery of a notable stellar phenomena, so I just wanted to record it for my own records. But otherwise, it's it's not it's nothing special really. Or like this place right here, I just found it to be a good imperial PvE site. But yeah, if you want to check this out, these are fairly good because you can get these materials very quick, and then you can just trade down everything. Because these are grade 4 materials, so the maximum grade you can get. Anyway, you have everything in a spreadsheet. Yeah, if once you start digging up this stuff, you'll find that people use a spreadsheet for everything. Spreadsheets are good for this game. Anyway, I have 2 potential guardian ruin bodies, but no brain trees here. We have a tubus. I can probably skip the tubus, at least for now. I'll just make a bookmark. Okay, all good. Ready to go to the next system. Almost done. Only 2 to go. And in fact, it's probably only 1 to go, but I'll do the 300 anyway. And I'm seeing that there's advertisements incoming, so what I do is I run 3 minutes of advertisements every hour. So at the same time I can take a break, you can take a break, you don't have to watch the ads at all. And then you'll get 1 hour advertisement free. Oh wow, 62 bodies. Talking about big systems. And of course no one has mapped it before. Alright. It's more for me. Probably gonna be a ton of moons. Because I don't see any other stars either. So it's just a lot of moons. Yeah, almost a waterboard. No problem. We'll take it anyway. We love all the planets. And of course, if you have any questions, I mean, feel free to ask. Hopefully I can answer them. Otherwise, we'll try to look for the answers together. This one is a water giant, which are not exactly rare, but fairly uncommon. Unfortunately, not valuable, despite their rarity. Well, relative rarity, but still a nice find every once in a while. Some of them can be particularly beautiful. Anyway, I at some point ads are going to start. As soon as they start, I'm gonna stop this. In fact, you know what? I'm gonna stop it right now, so I don't miss anything, and you don't miss anything. So I'll see you again in like 3-4 minutes, something like that. Just the time to get the ads over. Alrighty, everyone should be back from the ads. let's continue our mapping.
Carbon dioxide atmospheric landable with life. May host a marked biological. Body 10.
So, just to explain, for those who are not familiar with the type of work I'm doing here, I'm looking for guardian sites, guardian ruins, which are very hard to find, but if they exist in a certain planetary body, they will show up here under locations. There's gonna be a guardian, and then if I remember correctly, like a number in parentheses. I'm not entirely sure though. But it's gonna be like kind of a distinct yellow orange word here that says guardian. So that's what I'm looking for in this particular region.
Body 10C.
Of course,
Carbon dioxide
there's many other interesting things here. It's not just guardians. There's green trees almost everywhere. For once, earlier today I started on a shepherd moon that had a fumarole, which is kind of a rare one, kind of hard to find, and it was in a very beautiful moon. In fact, let me show you a screenshot I took earlier. This was the view earlier today. The moon is a shepherd moon, so it's very close to these rings. These rings are not rings of the moon, they are rings of a gas giant. And there's a sunrise which is blue on this moon. This is the fumarole with human and ship to scale, so kind of big. And this is a view from yesterday night. Same moon, but this is the gas giant, which is particularly beautiful because it's this kind of intense violet. You don't see many of these scenes. This was one of my favorite places ever. So I made sure I took some good screenshots of it. This game is a big time wallpaper generator, and if you're into things like planetary science, space science of any kind, you're in for a treat, because this game is surprisingly rich in things to learn about planetary science in general. Even if some things are, not exactly accurate, I mean, it gets very close sometimes. For example, just the fact that we have star spectral types. That is amazing. I knew of star spectral types before starting to play this game, but I didn't know them so well. I couldn't remember all of them. Now I know all of them, and I know what they mean. And there are not many games that can do that. That can inevitably, indirectly teach you something about science. Even if you don't want to, you're gonna learn something. This is gonna be a long one.
Body 8A.
More brain
Potential
trees.
guardian ruin body. Horizons biopresent. Body 8C. Potential guardian ruin body. Body 8D.
Okay.
Potential guardian ruin body.
Very red planet. Almost Mars-like.
Body 3A. Horizons biopresent. Body 3B.
Every once in a while, you can find planets and moons that look very similar to the ones you can find in our own solar system.
Body 2.
That's kind of a cool one.
Body. Horizons biopresent.
Nice shades of like dark yellow and gray, and rings too. Always cool.
Body 7B. Horizons biopresent.
Like for example, this kind of looks like Io. Io is a moon of Jupiter. Yeah. See? It's like this brownish yellow patches, brighter yellow, almost whitish, and then all the dark spots, which are actually volcanoes, all over the place. And in fact, there's silicate magma, kind of like on Io. That's kind of a nice example. Fairly common, especially if they are like 7A. A means that it's the first moon, the closest moon to the parent body. That typically implies strong tidal forces that tend to deform the moon so much that it causes a lot of internal friction and a lot of internal heat that melts rock and generates volcanism. Went through my profile. It's amazing. Yeah, no, I'm a planetary geologist. I for real, in the real world. Like once in a stream, I showed one of my papers that I recently published. I typically like to keep my real life separate from streaming. Not really for privacy or anything. It's just I want to keep them separate. But yeah, I'm an actual geologist. I don't have this stuff ready tonight, but typically if you want to, I can even show you a rock. Like I have rocks hanging around all the time that I can show you, but I need a second webcam, which is not connected, not set up right now. Let me see. Okay, 10B, 10 something like here. 10B, 10C and D, C, hopefully one of these will have the bio I'm interested in, which is a concha labiata. Concha labiata green. No, teal. Sorry. Concha labiata teal. Oh, thank you. I really appreciate it. I'm just reading your the second part of your message. I truly appreciate it. I'm glad you are enjoying it. I I typically always try to insert some science. Sometimes I don't. It's just, you know, the spur of the moment. You know, if I get inspired or if someone asks about things, then there's a good chance I'll share you something. Otherwise, I'm just here to have fun, right? So I don't like to force anything. Um, I'm streaming purely for fun. I'm not here to make money or anything. In fact, any money I make through Twitch goes entirely to donations. I'm not keeping anything, which is actually not very good for my taxes. But because I have to report whole income as if it was like including Twitch as if it was actual income, and it is taxed, but I mean it's so small that it doesn't really matter, so I'm happy to donate it. And currently the donation, the charity I'm supporting is Khan Academy, which I chose because they provide free access to basic education, which in my opinion is fundamental. I wouldn't be a scientist, I wouldn't be here if I didn't have access to affordable education. Like I'm from Italy. The vast majority of my education, all the way to my master's degree, happened in Italy, where, you know, going to school is free. Going to college is much cheaper than, for example, the US. Like my entire bachelor's and master's degree costed about the same as one semester in an average American university. One semester is equivalent to 2 degrees in Italy. And it's something I really dislike about our world, is how privileged you need to be to have access to good education. So Khan Academy is one of many, it's not the only one, charities that supports that, and they are very transparent about it, which I like. Oh, there's nothing here, so I need to go elsewhere. Probably to D. Actually, not C. For some reason I thought C had something, but D. So I'm supporting them. But I mean, I know there are many others that are also supporting access to education and making it easier for everyone to get good education. Yeah, and consider that the funny thing about education in Italy is that a lot of people think it's expensive, and I mean, in a sense it is, but at least Italy, you know, it has many problems, including in education, but I must say that it does a fairly good job at like making it easier to go, for example, to college. Like if your family doesn't have, a certain income, then you can get pretty good discounts on your tuition in Italy,
Body tending.
all the way to
May host a
getting free access to college. And I'm talking about public college, not private. Private, I have no idea. um, they may have some programs, but I honestly don't know. It's not perfect. The system has issues, but it's certainly easier than the US to get a decent education at least. Tonight I'm feeling the opposite of last night. Typically I stream on Mondays, Thursdays, and Saturdays. Although in the last 2 weeks I've been so busy that I thought I would have time to stream, but by the end of the day I was just too tired. And yesterday night I played like an hour and a half, and I was literally falling asleep in front of the computer, so I was like, okay, I need to stop. But tonight I'm barely sleepy, which is okay in a sense, but also not great because tomorrow morning I need to wake up kind of early. But if I'm not sleepy, I'm just gonna be sitting in the bed looking at the ceiling. Okay, well, that was canned. I don't think I'm gonna bother with sampling. It's not that special. Instead, I want to visit one of the grain trees. Oh, and I need to write down something. 1, 2, 3, 4. 8 grain trees and 5 potential ruins. Well, 5 bodies potentially with ruins, but none of it, unfortunately. So we are at body 10, the closest one. Which one is the closest? 7? 7B. Sometimes this game can also be very relaxing. Now, possibly the best thing about this ship is that if you can't find the bio here, then you can boost. and you can boost fast. It's also kind of dangerous, especially if you're like me and you're carrying like under 66 millions in exobio data. Before bonuses, so more than 800 millions. But it's fun. There they are. It's gonna be gypsum. This one I'm pretty sure is the gypsum. Yep. And this one is rosum. I'm gonna check a few other clusters just in case, but that's probably it. Yep. That's it. Alright. Last one. 300. An F star and a K star. That could be a fun one. Watch Pisces.
Body weight. Meets mapping criteria. Body 2. Meets mapping criteria.
We will map them.
System discovery complete.
Let's see.
First
Yeah.
body to map is 2.
Nice and easy. They're close by, they're binaries. Quite valuable too. Like 2.6 millions each. Like often high metal contents that are terraformable are more valuable than like water boards. Especially water boards that are not terraformable. And certainly more valuable than even most other planet types that have been already discovered by someone else. Often neglected, but it's a good way to rank up in the exploration rank. The speed with which the neutron star's spinning game is not unrealistic. That's a very good question. To be honest, I don't really know. I'm gonna say yes, because I know some pulsars, which are neutron stars that are particularly active and have these polar relativistic jets of material can spin at many times per second, like tens of times per second. In fact, pulsars are often discovered by the radio missions because it's like this repetitive, very regular radio emission. So presumably they can also be very slow. So they are heavy, but okay. Let me first show you some. If there's, I think there are GIFs and videos of pulsars. Yeah, like for example, this is one in the optical and X-ray wavelengths. Like the pulsar is, I think, this one, this star at the center. And these are the jets 1 and 2, and this is the disk around it too. So to my knowledge, yeah. So the reason for why they rotate so fast is angular momentum. It's the same case as a ballerina spinning. It's like a classic illustration in physics for the angular momentum, or better, the moment of inertia, and how it changes. So what? This is not what I wanted to see. Come on. Oh, wait. This is good. Nah. If it was... No. Let's see if I can find maybe in this video. So what? Now this is, come on, there must be some a good example, because like if you see it visually, it will be like so obvious. Like I don't have to hand wavy like explain it. This is a static image. Well, so a ballerina initiating a spin typically starts the spin, or a skater starting a spin, same thing. Basically will start a spin with their arms and usually one leg extended to just kick off the spin. And if they keep their arms and legs, one of the leg extended, the moment of inertia is gonna be large and it's gonna spin slowly. But then as soon as they wrap up their arms along their bodies and leg as well, then all of a sudden from a large body you're going to a much smaller one, a much thinner. The moment of inertia changes, but the angular momentum, which is a description of the amount of like momentum, like the amount of motion that an object has, needs to stay constant, is conserved. So independently of the shape of the object. So as the object, in this case the ballerina, shrinks, is gonna start spinning faster. And then if they open their arms again, then she is, or they are going to spin slower again. And you can, in fact, in some cases, like I thought of a ballerina more than a skater, because sometimes they go through different positions, and depending on the position, the speed changes. It's part of the choreography, it's part of the exhibition, right? The same exact thing happens to neutron stars, and really to the parent star, the star that was there before the neutron star. So neutron stars form from large massive stars, like typically supergiants or very large giants. So our own sun, our own star, is not massive enough to form a neutron star, but it will form, for example, a white dwarf, which is a fairly similar object, and white dwarfs can also spin very fast. And that is because the original star is spinning, but slowly, because it's very large. But then once the star goes red giant, well, a giant or a supergiant, and then in the case of a neutron star goes supernova, it will shed all the outer layers. The only thing that is going to remain is the core, which is very dense and very small. So even if it is very massive, still a few solar masses, it's going to be very, very tiny compared to the big size of the initial star. And because the angular momentum is going to be largely conserved, well, some of the mass is lost, so technically the angular momentum changes, but most of it is going to be conserved. It's going to be so much smaller that it needs to spin very fast, and in some cases they can spin many times per second. And if it was even smaller, then it would rotate even faster. In fact, there are some black holes which apparently spin, and spin so fast that they are close to the speed of light. Which makes some cosmologists and some astrophysicists very uncomfortable, because when a black hole starts to spin, strange things start to happen. They get much more complicated to model and predict in their behavior. In fact, we don't know exactly how. Well, we barely know how a non-spinning black hole may behave. At least we have a possibly good idea. A spinning black hole is a whole different level of nightmares. And there are some black holes. Somewhere in Wikipedia there is a list of spinning black holes. And some of them are like 0.98 c, so like 98% the speed of light. And I don't remember how they know they are spinning, or how fast, but they do. Here. There we go. Here. Astronomers find the fastest spinning black hole to date in 2021, so they might have found an even faster spinning one. Or does it say? I don't want to read the whole thing. Let's find the article. It's easier to read the article. Come on. I have no idea what a lot of this stuff means. Just give me the juice. How many C? See, this is a good example of a paper that is hard to read for a non-expert. I know. It is here somewhere. Not here though. Now I need to find it. It may be here. Otherwise I know what to look for. Because it's going to be a naked singularity. I think it's called a naked singularity. And I'm sure where is that table? Well, I guess you'll have to believe me. Here. Here. Oh, maybe they removed it. So this black hole, this number right here, very ED-like, has a spin parameter larger than 0.82, and 1.0 is the theoretical maximum, which is the speed of light. So at least 82% of the speed of light. That's how much is spinning, how fast is spinning. And it's spinning at another 50 times per second, the black hole itself. But what they look for is the radius of the event horizon. So it's the event horizon, I guess, rotates with the black hole itself. So if it is spinning, it's gonna have this shape right here. This is a cross section. So the edge of the event horizon is, for that black hole, is spinning at least 82% of the speed of light. Yeah, let me look at that. Nope. No, not this one. I want to use the browser. Yes, this is probably. Oh yeah. This is probably a good article. And yes. And in fact, earlier today, I was watching a video by Veritasium, which I highly recommend if you're interested in this stuff. Veritasium. Here, this video, he just released it.
You can never see anything enter a...
Stop. There we go. I'm gonna paste it in chat. It's kind of a longer video, 37 minutes, but trust me, this is one of the most interesting videos from Veritasium that I've ever seen. And I enjoy every single one of his videos, but this one is, in my personal opinion, is at the top. Like those 37 minutes, well, subtract like a couple of minutes for advertisements at some point, is like every single minute is worth it. And it's gonna talk about spinning black holes and white holes and universes, possible parallel universes. It's very interesting, so highly recommend to check out this video. Highly recommend. Can this motion conservation, the momentum, the angular momentum, conservation of angular momentum, be said as the reason why the asteroid mission of NASA changed the orbit of the impact of the asteroid? Like, we changed the shape of the asteroid, and so its speed increased or decreased? Not quite, but you're close. In that case, it's a conservation of kinetic energy. So, or kind of, really, because in that case there was a small asteroid which was actually the moon of another asteroid, and they used a very high speed impactor to change the velocity of the bigger object. So there's the energy that an object has due to its velocity is described by the kinetic energy equation, which is 1/2 mv square. It's probably gonna show here. No, I misclicked. There we go. 1/2 mv square right here. Let me make it larger. Where m is the mass of the object and v is the velocity of the object. So if you want to change the velocity of an object, you either somehow add, subtract mass, or you change its kinetic energy. One way to change the kinetic energy is to have another object with a certain mass and a certain velocity impact with the object that you want to change the velocity of, right? So in the case of the NASA mission, which is DART, DART, they used a small spacecraft, like a few kilos or a few tens of kilos at most, but which was going very fast compared to the asteroid. With, from the reference point of the asteroid, or better, the asteroid moon, the spacecraft was going very fast, and the kinetic energy increases with the square of the velocity. So if you double the mass, the kinetic energy will double. But if you double the velocity, the kinetic energy will increase 4 times, because it's the square of 2. So if you triple the velocity, it will increase by 9 times, 4 16 times, 5 25 times. You can see it's kind of an exponential curve. It's a geometric power law. So essentially they made the spacecraft go as fast as possible, and then it hit the moon of this asteroid. And even if the mass of this spacecraft was very small, the kinetic energy was actually sufficient to cause a detectable change in the velocity, and also therefore the trajectory of the asteroid. And they didn't really need to change it by much, just slightly enough, just a small enough quantity that would be sufficient to redirect an asteroid that is very far away from the Earth and make it just barely miss Earth. Because if it is very far away, even a very small change will then become larger and larger and larger once it gets closer to the Earth. Because if the trajectory changes by a tiny little angle, if you're going to travel very far away, this angle is actually going to convert to a fairly large distance. And it was incredibly successful. In fact, it was way more successful than they ever predicted. And that was due to the fact that the asteroid was most likely a rubble pile. So just literally a pile of rocks. So fairly low density probably, and also fairly low cohesion. So when it impacted, it actually blew off like a ton of material. So not only it absorbed a lot of the kinetic energy very well, due to the fact that it wasn't very compact. Didn't they just scan this guy? Why? I'm confused. Oh, I scanned both of them. I didn't realize. But yeah, it was very successful. First, I don't know if you saw some pictures, but of the event, but like the images show like so much material being ejected. Which in part contributed, because, like, as I said, you're actually in part correct, because in part the impact changed the shape of the object. So in part it must have also changed, like, for example, its rotation property, which can affect the trajectory over the long terms. Yeah, this is it. So those are actually, it's only one dot, but it's actually the two asteroids, the main one and the moon. And once the impact happened, like there's this cloud of material being ejected away, which greatly contributed um, to the change in trajectory. Oh, I see advertisements are in, so I'm gonna take a quick break. Alrighty, everyone should be back from the ads. Sorry about that. I didn't realize an advertisement was coming in. I also didn't realize how late it is. I will need to force myself to sleep. So I already jumped to the to the last system for the night and for my assigned voxel survey. It's kind of a big one. In fact, I think the largest I've found so far, possibly. Although I think I found one at 70 something. Looks like a lot of moons. First I'm gonna map all the gas giants if I can, because that makes my life a little bit easier later then. Because if you don't map the gas giants before, then the moons won't, like, I don't know how to say, like, kind of click in, like be actually recognized by the FSS. nice.
Ringed landable body.
That could be a good spot to stop for the night. Okay.
Body A4E. Closed binary relative to body size.
The overlay is part of the well, it's a plugin in EDHM.
A4G. Potential guardian brewing body.
I didn't pay attention there. Okay. I don't know if you're familiar with EDHM. Let me see. EDHM UI is one of the many third-party tools, in this case to change the appearance of the UI. It's gonna put, this is what it looks like, and I probably need to update it. Not now. So if you get this, if you don't have it already, then you go to main menu, 3P mods plugins. For me, I'm pretty sure it was already there. There's a plugin, or maybe I downloaded here following this link. I honestly can't remember. There's a plugin which is called FSS Overlay, and from this tab you can actually select your favorite. Mine is this one, but I actually modified it by looking into the actual, it's an image file, and I slightly edited it because I didn't like the vertical bars. They were too bright, so I made them like 50% transparent or something like that, so they are a bit dimmer. The problem then is that they must have changed the appearance of some of the bodies in a recent update, or maybe it's ADHM not working too well with the most recent update, but it kind of looks like it was just the update changing the color of a few bodies. So now the colors don't correspond anymore. For example, water wards used to be red, now they are blue. Ammonia wards used to be blue, I think, and now they are gray. The rest is almost the same except gas giants, which used to be, I don't remember, gray or yellow, and now they are orange. So the colors don't correspond much anymore, but it doesn't matter. I mean, I'm mostly using it for, you know, as a first visual thing, just to say, oh, there's an ammonia ward, or there's something else. It's mostly just for aesthetics. But I can see how it could be useful to learn where bodies are in the FSS. Not that it really matters, but if you're into exploration and if you want to learn something else, well, that's one of the many things to learn in this game. Yes, I did hear about the new ships, and in fact, I'm really excited to see what they look like. In fact,
Carbon dioxide atmospheric landable
I know
with
that Rayman is tomorrow or the day after is
carbon dioxide atmospheric
is going to show it, because he's a
body A10G.
Frontier partner, so he has early access to the ship. And let me give a shout out to him if I can remember how his channel is called. I think, yeah. No, why? What? Why is it? What? No, maybe it's just Rainman Games. Why is it Linky Mine? Rainman Games? Rainman Games. There it is. That's the one. Disregard the first one. I think he said tomorrow. Let me check. Yeah, May 1st. So tomorrow, he said he's gonna be live early. Sometimes I wake up and he's already on, so I don't know what early means. But early morning US time, I guess.
Meets mapping criteria.
Like he's on the East Coast, so
Horizons biopresent.
yeah, if you're interested, I don't know if any other channels are doing it. I know of him.
Body A18.
Is going to show the Python. So if I have time tomorrow morning,
Body A8F.
I'm gonna
Potential guardian.
be there. And in any case,
Body A8C.
check out his channel, leave a follow. He's amazing. He's one of the best thing that happened to our community. Like he's so nice and so supportive. He is such a great person.
Potential guardian marine body.
And so fun too.
Body
You will have a great time in his streams, and he's a professional streamer too. So streaming is literally his job. So like it's almost exactly the opposite of me. I stream for fun. He does it well for fun too, but also
Body A6B.
because it's his job.
Earth's orbit. Horizons biopresent.
Yeah, almost an Earth-like, but I saw it was like a little bit here on the side, so I didn't really have any
Body
hopes.
A2. Horizons biopresent.
Okay. All right, last one.
Body
No.
A1.
Yeah, it had
Horizons
a,
biopresent.
it has brain trees, but no.
First body to map is
Um,
A7.
No Guardian Ruins. Alright. I think I'll have to call it for tonight. I'm going to make some bookmarks for tomorrow, probably. Maybe. Not even sure if I have time to play tomorrow. And then I have to make bookmarks for at least the body here. Let's find something more kind, because 1.3 G, yeah. I don't want to risk it too much. Let me see. Then some statistics. 1, 2, 3, 4, 5. 5 brain trees. Seven potential ruins, and there are some bios too. CDG. C D and G. All right. Is this the ringed body? It is the ringed body. I'm gonna go there, because this is a nice one. And I need to visit it anyway. So that's a good excuse to go there. Yeah, I need to go. Because that one is valuable. It's like almost 2.8 millions. It's like one of the most valuable bodies you can ever find. Kind of high gravity, 1.3 G. So more massive than Earth, I'm guessing. Probably significantly more massive. Probably like 2 or 3 Earth masses, I bet. Well, 1.5, but it's almost the same radius, so it's denser, more compact internally, I guess. Oh, going a bit fast. There was a strange artifact showing up. It's like, I don't know if you saw it, it's like a purple light. It's the one for the ring. And then maybe find a good spot near the poles. Oh, brain trees, so I don't have to go. Look at that. I can do 2 things at once. So I don't need to go to this other planet here. Should probably go even farther away, closer to the pole, so I can see the ring. See if it is still visible. Oh yeah, big time. I saw someone I wanted to raid, but looks like they already raided someone else. You know what? I think today I'm gonna take you to someone new. Someone new to me as well. It's like there's quite a bit of explorers on tonight, which is always nice and good. Ah, crap. Was a bit too aggressive there. Come on. I completely forgot about the gravity. That's what is pulling me. I'm barely moving, like, hands off. And then I'm still crashing. Come on. There we go. Let's see if there are any other types of brain trees. Rosium. All rosium. Alright, well, let's park right here, next to these rings. Next to these brain trees, I meant. Maybe take a quick picture. Oh, maybe this way. Oh yeah. Perfect. Alrighty.